So in the previous video, we'd seen how we can do heteroscedasticity robust inference using the coef test function in the LM test package. Now, what we got here in our output were robust standard errors, right? And we were comparing those to the standard errors that are produced under OLS. So these are modified to account for heteroscedasticity, but these are unmodified, right? The ones that you have here. So obviously, since you know the coefficient and you know the standard errors, we can also report the t-statistics. And so, here we know how to do statistical inference and talk about whether a variable is significant or not. However, there could be instances where we want to do joint hypothesis tests or work with F statistics. Okay. And like we said earlier, the problem with heteroscedasticity is that it affects statistical inference, right? It causes problems for us in terms of statistical inference, whether it relates to t-statistics or f-statistics. So again, the way since we've been able to modify the t-statistics, we can also do a modification for the f-statistics in a similar way. And you're going to be, maybe surprised to find that sometimes there are very big differences between the usual f-statistics and the robust f-statistic, okay? So let's take an example here with the same regression that we had estimated before. So recall in the previous example, we were basically trying to explain the quantity demanded for eco-labeled apples. And we said that is based on the price of eco-labeled apples, the price of regular apples, and then a bunch of other variables that capture family income and how many people in the house in the household are or fall into different age groups, and also on the age of the head of the household. Okay, so this is what we were working with, and let's say we wanted to do a joint test. So we're setting up our null hypothesis here, and the joint test basically is going to give you the, when you do the joint test, you need to state the multiple exclusion restrictions. And let's say we take everything other than the price of regular and eco-labeled apples, right? So everything else is on the right-hand side. We put into our null hypothesis, and we want to see if these are jointly significant. So in the regular world, right, the way you've seen F statistics is the following. So we basically use the linear hypothesis command, and we state the OLS regression, and we state the multiple exclusion restrictions, or we state our null, and then basically this is the test, right? This is saying jointly these variables are 0, right? So you're basically comparing a restricted model which does not include these variables to an unrestricted model, model 2, which is, using the full set of variables. And you're seeing if there are, significant differences between the two. So notice here that the probability is 0.27, which is higher than 10%, right? And so, or 10%, right? So 0.1 or 10%. And so here we are saying that we fail to reject the null. Right? We fail to reject the null that these are, and the null said that these are jointly 0. Okay? But if you were to do heteroscedasticity robust inference for that F statistic, you're going to modify your code a little bit. Okay, so you're going to say linear hypothesis on your, whatever your regression is, whatever your hypothesis is, and you're going to basically say now alter the variance covariance matrix here in this way. We'll see options in the lab, but basically you're going to do the same thing here, just adding this one little argument here. And you're going to find that sometimes it happens that the probability is going to change. So the p-value here is 0.03. So we can actually reject the null at 5%. Okay. And so these are starkly different results that we get. And this happens when we're not accounting for heteroskedasticity, when heteroskedasticity may be present. I'm saying maybe because we still haven't tested for heteroskedasticity, which we will see in the next video.